Machine learning model development. When we are given with a set of data, we can develop a machine learning model by following certain steps. Suppose we have the data. The first step is to divide the data into two sets called training set and test set. We use the training data set for making the model with the help of any one particular algorithm, and the test set is applied on this model to get some prediction results. And this based on the results, we will find out whether this model is accurate. There are some evaluation metrics used for that I will explain in the next slide. Based on the result of evaluation, we will take a decision whether to redo some inside the algorithm. If some rework is required, that is done, and final model will be developed. And when the model is ready, you can use the actual production side data and do the prediction. So this is how we make a machine learning model. Now let us see the evaluation criteria or the metrics used for performance evaluation of classifiers. We have seen that machine learning models are used for classification, regression, clustering, etc. These are the performance metrics used for evaluating classifiers. Accuracy score, confusion matrix, precision, recall, and F1 score. Accuracy score, as we know, it is total number of correct predictions, true positives and true negatives, divided by total number of predictions. So this is a case where we want to classify the item into two sets, say positive and negative sets. So in accuracy score calculation, the true positive and true negative predictions, the total number is written in the numerator, and true positive, true negative, false positive, false negative, all the items that we are checking, the total number of items that we are checking is written in the denominator. So then we will get accuracy score. The accuracy score value is always between 0 and 1. If all the predictions are right, the total number of actual correct predictions and the total number of predictions are equal to 0, then we will get 1 as the accuracy. If none of the predictions are right, we will be getting 0 as the accuracy. Okay, next. Let us see one limitation of this accuracy metrics. Suppose we have a two-class classification problem. Let us take an example. We are given with the information about some 10,000 cancer patients. Out of this 10,000, suppose only 10 are actually affected. Okay, so if we consider class 0 as the people who are not affected with cancer and class 1 as the people who are affected with the cancer. So the class 0 examples are 9990 and class 1 examples are 10. Suppose our model predicts that all the 10,000 people are not actually affected with the cancer. Then how accurate this model is? This model is predicting that all the people, none of the people are affected with cancer. That means all 10,000 are in class 0. Okay, so in this particular case, the accuracy score is calculated as the correct predictions divided by total number of predictions, where the correct predictions are 9,990 and total predictions are 10,000. And the result is 99.9%. So this model predicts it is having a 99.9% accuracy. But this model is not suitable for our purpose because it is not at all identifying the cancer patients. So this kind of limitations are there when we are considering the class information also. So we want other performance evaluation metrics to study about the machine learning models. So the other metrics used are confusion metrics, precision, recall, and F1 score. And the first diagram that is shown here is the confusion metrics. In confusion matrix, the true positive and true negative values are written as diagonal elements, and false positive and false negative values are written in these positions. So true positive value shows the items which are items of class 1 which are correctly predicted. True negative shows the items of class 2 which are correctly predicted, and the other false positive and false negative are wrongly predicted. When we study the iris species recognition example, I'll explain more about this confusion metrics. Let's see the other three evaluation criteria also: recall, precision, and F1 score. Recall is true positive divided by true positive plus false negative. Precision is true positive divided by true positive plus false positive. F1 score is the harmonic mean of recall and precision. It is calculated with the help of this formula.